Okay, so hopefully you can see whatever I write here. So we were talking about differentiation rules. Yes, so let me write the title. Continue, yes. So we started actually talking about differentiation rules. The differentiation is the process that will take us from the function to its derivative. So the final product is called the derivative. The process of going from the function to its derivative is called differentiation. So instead of saying determine the derivative of a function, I can say differentiate a function. Okay? So and then I started, if you remember, I wrote some generic rules that are correct for all type of functions. So we learned that the first one is that if I have a function and if c is a constant, if I multiply c by f and then I want to take the derivative, we actually proved the harder one for the sum of the functions. And we realize that this becomes c multiplied by the derivative of the function. And we also learned that f plus g, its derivative, is equal to the derivative of the first part plus the derivative of the second part. And if I have more than two functions, the rule is still the same. I can do this process. And then if I have the subtraction, I can write the derivative of the first one minus the derivative of the second one. And then I emphasize that you need to wait a little bit to see what would be the correct formula for the derivative of the product of two functions. And I told you that make sure that you understand that you will never make this mistake, that you can take the derivative of the first one, derivative of the second one, and multiply them together. So that's a wrong formula. And then this one is also wrong. If I have a fraction and I want to take the derivative of a fraction, I'm not allowed to take the derivative of the numerator, take the derivative of the denominator, and simply divide them. These two formulas are wrong. We will correct them later in this course. But these are the things that we know from Math 3C. And if you remember in the previous session, I gave you the rigorous proof of this part. And you can prove these two things similarly yourself. Okay, and if you remember, let me write, is it visible? Yes. Let me write the table here. So we had this table. We have f of x, and we have derivative here. So here we have a constant function. So c is a constant. C is a constant. The derivative of c is 0. And then we learned that if c is a constant, x to power c, we talk about this? Yes. We learned that this becomes c to the power of c minus 1. Again, c is a constant. But I told you that there are some special cases that it is better to remember individually, separately, even though it is not mentioned in the formula sheet. This is the only one given to you in the formula sheet. And then the special cases are these. So let me write them in blue. Yes. So I have here x. The answer is 1. If I have 1 over x, the answer is minus 1 over x squared. And then if I have the square root of x, the answer is 1 over 2 square root of x. So I would write a special important cases. Important special cases. special cases. I would prefer to remember them separately because they will happen over and over again in your calculations. And if every time you want to use the formula to calculate them, it would be tedious. Okay, and then I was talking about different types of functions that you can take the derivative so far just by these two formulas in the table and these general rules that we have so far. Okay, so if I remember correctly, I wrote something on the board and we didn't solve that problem. I don't know which number was that, but if I remember correctly, it was something like this. 2, I think, third root of x and x plus 1 to power 2. If this is not exactly the case, there are minor differences. So let us keep it like this. So assume that you want to differentiate this function. It means that I want to start finding the final product, which is called the derivative. Okay. So you see, this function in this form is not in your table. Yes. So the only thing that you need to improve your skills on is to change the form of your function into a form so that I can apply these rules and the formulas in that table. Okay, so it's important to have this skill. Okay, so what should I do first here? Let me just refresh your memory.
Mama?
Yes? Yes?
It was 3 third root, right?
This was 3? Yes? Do you mean this? Okay, so let me write that one.
Yes.
Okay, but the rest is correct? Yeah. Is this the correct one now?
Yeah, the rest is correct.
Okay, thank you. So I will start doing this. So you see that this formula, this function is not in my table. So it means that if I want to differentiate this function, the first thing that I need to do is actually reducing the form of my function into functions which are combined using these 3 rules, okay, and are those functions in my table. Okay, that's not hard. So what I do, you have enough experience now. So the first thing that I write is that f of x is equal to 3. Instead of this one, I can write x to the power of 1 over 3. And instead of x plus 1 to the 2, I can raise it to the power of 2 using the identities. Yes, so the first one to the 2, 2 times the first one times the second one, and the second one to the 2. So it's not enough yet because that's written in the form of a product and still we don't know the formula for the product. So it means that I need to multiply. Yes. So what I do is that 3, let us do it in our head. Yes. X to the power of 1 over 3 multiplied by x to the 2. Because the bases are the same, the exponents are added. So 1 over 3 plus 2 is how much? Is 7 over 3. And then you multiply this by that, it becomes 6x to the power of 1 over 3 plus this exponent, which is not written, it means it is 1. So it becomes 4 over 3. And then the final one is 3x to the power of 1 over 3. So this means that the first 2 steps was actually including how to reduce my function into a familiar form. Now I can use these rules. I want you to understand them, but I don't want you to spend time on writing them, yes? So if I want to start differentiating this, I have the sum of 3 functions, so I need to apply the sum rule to this one, to this one, and to this one. And then each one of them has a multiplicative constant, so for each one of them, I have to apply the first rule. And then I have a function which is in my table, okay? This is the way that you need to understand. Think in this way very quickly, but you don't need to write it down. And then try to write as less as possible, okay? So f prime of x is equal to, you write this one, 7 over 3 goes down, multiplied by 3 becomes 7. And then I have x to power 1 less. 7 over 3 minus 1 is 4 over 3. Yes? If you have any questions, please let me know. And the next one. 4 over 3 goes down. Okay, so 6 is here. 4 over 3 goes down. I am supposed to multiply them. This 3 and this 6 are simplified. 2 times 4 is 8. And then I have to subtract 1 from this number. So it becomes 1 over 3. And then finally, 1 over 3 goes down. 1 over 3 and that 3 will cancel out. So no number 1 is left. And then I have x to the power 1 unit less, which becomes minus 2/3. Yes? So that is the final product, which is called the derivative. And you see that the derivative is a new function which is derived from the original function. That is why we call it derivative. Okay? So it's a product coming out from the function itself. But remember that the derivative itself is a function again. So whatever you can do with a function, you can do with your derivative. For example, you can ask, what is the derivative of this function? Yes? So I will talk about that later. Any questions so far in how calculate the derivatives? Okay, so I want to expand this example a little bit to cover whatever I suppose that you need to know. Okay, so if you don't mind, let me clean this example and start writing this properly. These are the rules that I think you can remember them easier. Okay. So let me start a new, fresh example, but that is in continuation of that example. So example, differentiate, okay? So number 1, so let me write the function f of x equals to, let me work with fractions now. So let me write 3, 5, x to power 2. So assume that I want to take the derivative of this function. Okay, so this function is not in my table, so my duty is to reduce the form of this function into that form and combine with these rules. The sum rule, the difference rule, and that simple product rule. Okay, so what should I do here? So the first thing that you need to do is to write 3 here, and then x to the 2 goes up. It becomes x to the negative 2, and then you have it 5. And I hope that you realize that even though this is a fraction, but this is not a very serious fraction because this is a number. So you can write it as 3 over 5 multiplied by x to the minus 2. So this you need to immediately write it in this form, and then everything is ready to differentiate. Yes. So f prime of x is equal to, so you have 3 over 5 minus 2 goes down, and then x to power 1 less, which is minus 2 minus 1. And then what happens? It becomes minus 6 over 5 x to power minus 3. If you want to, you can put it back in the form of positive powers, but that's not compulsory unless you want to do some calculations with the derivative itself. So then it becomes minus 6 over 5. I take this one to the denominator and make it positive. So that is one scenario. So if you have any questions, please interrupt me. Okay. Now let us go back. So if you don't, do you have any questions now? Okay. So let me give one more example. I will solve some more examples of this type of fraction types. Okay. So for example, yes. So yes. Yes?
Why didn't you multiply the 2 with the 5?
Pardon? So that's the problem. Now I can increase the volume because now you are muted. So let me just increase the volume so that I can hear you. Okay, please repeat it more. Hello?
Yes, in the fraction, why didn't you multiply the 2 with the 5, like 3 divided by 10x?
Here, you are talking about this example on the board? Hello?
Yes, like 3 divided by 5 and x squared.
So let me repeat it again. 3 over 5x squared. What I did, I brought this up and make it negative. Yes? And then instead of writing it in this form, I write 3 over 5 multiplied by this expression so that I can use this rule. C times f prime is equal CF prime. So this is a multiplicative constant prefactor, and then this is x to the power of minus 2. Then when I want to take the derivative, I need to keep this number as it is, exactly like here, and then concentrate on taking the derivative, differentiating this part. Differentiating this part means minus 2 should go down, and then I need to write x to power minus 2 minus 1. Yes? And then minus 2 multiplied by 3 over 5, it becomes minus 6 over 5. So this is why I have written minus 6 over 5. And minus 2 minus 1 is minus 3. As I told you, it is enough to stop here, but I myself prefer to simplify it a little bit more. So I brought this back to the denominator to make it positive. So I don't know if I could answer your question. Did I?
Baba, can I ask a question?
Yes?
Yes, I understand. Thank you.
Yeah, you're welcome. So number 2. So let me give you another function here. So let me call it g of x this time. Let me make it simple first. So assume that I have x to the power 2x to the power of 3 plus 2 x plus 1 divided by x to the power of 5. Let me also put a number for it, 7x to the power of 5. So assume that I want to differentiate this function. So what should I do? You might say that we haven't studied that yet because that's a fraction, and then we haven't studied how to take the derivative of a fraction. Yes, that's right. But this is an exception, and I want you to remember this exception. Otherwise, you will suffer a lot if you want to use the quotient rule. The quotient rule is a fairly complicated formula. So I will myself avoid it if possible. Yes. So these are those type of fractions that it is possible to avoid the more complicated quotient rule that will come later. And what is the rule? The rule is that if your denominator is one single term, try to learn this trick, okay? So let me just emphasize it here. So if I have a fraction whose denominator is one single term, even though you can apply the more complicated quotient rule that we will learn later, but still, I would prefer to avoid that because there is a simpler way to do that. Okay, that's up to you, of course, later that we have all of them. So can you tell me what would be the trick here? These are actually, all of these things are Math 3C problems. They are not Math 4 problems at all. So how should I solve this? How should I differentiate this function at this level?
Split it into 3 terms.
Exactly. So remember this trick. If you are facing a fraction whose denominator is one single term, it's not added with something, it's not subtracted from something, just one single term, then it's always have this trick in back of your head that you can split it into 3 terms, okay, or more terms, of course, depending on the number of terms that you have in the numerator. In this case, I would write g of x is equal to 2x to the 3 divided by 7x to the 5 plus 2x divided by 7x to the 5, and then plus 1 divided by 7x to the 5. And then take your time to simplify it. If you can do it quicker, it's better. So if I want to write this one, 2 over 7 is just this. X to the 3 divided by x to the 5. So it becomes x to the 3 minus 5. The exponent in the numerator minus the exponent in the denominator, so it becomes minus 2. And then this becomes 2 over 7. And then what I have is x divided by x to the power of 5. So it becomes x to the power of 1 minus 5, which becomes minus 4. And this one, there is nothing I can do. I just bring it up. So it becomes 1 over 7, x to the power of negative 5. So now everything is in order. I can use these rules of sum, the sum rule and the multiplicative constant rule together with these formulas in my table. Yes. So then let me just do it quickly. So g prime of x is equal to, so minus 2 goes down, will be multiplied here, so it becomes minus 4 over 7, x to the power of 1 unit less. Minus 2 minus 1 is minus 3. The next one is minus 8 over 7, because minus 4 goes down, will be multiplied by 2. It gives me this number. And then I will have x to power minus 5, 1 unit less. And then minus 5 goes down, so it becomes minus 5 times 1 divided by 7, x to power 1 unit less, which is this number. This is, of course, you can leave it like this. If you want to, you can bring these numbers back into the denominator and simplify them. But my point here is not simplification, assuming that simplification is something that you already know. Okay? So even in the exam, it's clear you can keep it in that way, but might be I want to ask what is the exact value of the derivative at a given point, at a given number, so then you need to put that number here, and you should be able to simplify that number at the end, okay? So simplification is something that you need to know very good. Okay, any questions here? So remember the type of the fractions that this method will work. The fractions in which the denominator consists of only one single term, yes? This is the best way to do that. For example, if I give you this, if I give you 5x plus 2 divided by x plus 5, x plus 3, for example, this one, this you cannot use this rule. Yes? So then you have to use the quotient rule or some product rule in a way. This is not one term. It's a fraction. The denominator consists of two terms, not one term. So this method will not work for this. If I want to decompose it, what I can write at most is to write 5x divided by the whole thing plus 2 divided by the whole thing. Okay, but this is not simpler than the original problem that much, because still this remains in the form of a fraction and it is not reducible to this. If I bring it up, what I can do, I can write x plus 3 to the negative 1. But x plus 3 to the negative 1, I cannot open it up. Okay, so I cannot open it up so that I can multiply 5x in. So this means that here, even though this is a very simpler fraction than this one, apparently, but then we have to use the quotient rule, the rule that tells me how to differentiate a fraction in general. Okay, so that's why you need to remember. But remember that whenever you can do this, it's better to do this, even in the future that you already know the quotient rule. So I want to give you another example. Wait for you a little bit so that you can solve the problem, okay? So number 3. So let me write, for example, another function, call it h of x is equal to Let me make the computation a little bit cumbersome. So 5x squared to make sure that you can do everything correctly. And then minus 2, the fifth root of x plus 2x squared. Then you have 3x to power 5 square root of x. Okay, so I'm just making it very cumbersome because I want to make sure that if you can safely do this, it means that you already know everything, more or less. Not only just this, the previous ones and the previous ones. Okay. I can wait a little bit for you. Okay, at least I hope that you understand what is going on, even if you haven't finished the problem yet, but I don't think it's very hard. So first of all, it's a horrible fraction, I agree, but the good point is that the denominator consists of only one single term. Yes? Yes, Alex?
I was able to finish it just as you started explaining.
Okay, good. So
It was just enough time, I think.
yeah, no problem. So it means that at least I hope this. What I want you to know is that how to deal with this fraction here. The guiding point is that I have a fraction, but the good point is that the denominator consists of one single term. So whenever this happens, I don't need to be worried that much, because if I have an extra term, then it would be really horrible. So you need to use the complicated quotient rule that we'll learn later. So the first thing is that I simplify this. And when you want to simplify this, simplify it as you are comfortable with this. So if you can do something in your head, do it, okay? But let me just write everything here. So first I decompose it. So this becomes 5x squared. The third root of x. Might be you are easier first combining and then decomposing. That's up to you. So this is the first term, and then I have a negative sign. So it becomes, the next one is this. 3x to the 5 square root of x. And finally, the last one is 2x squared divided by 3x to the 5 square root of x. Okay, so there are simplifications possible. I don't know which one is easier. So let me just do a lot of things in my head. Yeah, so this x squared and this x to the 5 are canceled. X to the 3 is left in the denominator. Yes? And then I know that 5 over 3 should be written as a factor. x2 is not there, but I have x to power 1 over 3. And then I have x to power 3. And then I have x to power 1/2. So you see, x to the 2 is gone. Third root of x is written in this form. x2 is cancelled with 2 of them here. x3 is left. The square root of x is this guy.
X to power 5.
Pardon? Pardon? X to power 5 is simplified with x2.
Isn't it x to the power of 5? Not x to the power of 5.
This is x to power 5, but x to the power of 2 is simplified with that one. This is gone. Okay, so let me write it. So x to power 2 and x to power 5 are simplified here. So I will have the third root. So this is gone. This is the third root. X to power 2 and x to power 5, 2 of them and 2 of them are gone. X3 is left. X square root of x is x to power 1 over 2. Yes? If this is not correct, please let me know, but I think it's correct. And then I go to the next one. I have 2 over 3. Fifth root of x can be written as x to power 1 over 5. Then x to power 5 multiplied by x to power 1 over 2. The next one is 2/3. x2 and x5 are cancelled. So x2 is cancelled with x2. I have only 1. x2 is cancelled with that one. x3 is left. And x to power 1/2 is left. Okay? So that's the first step. And then what I do, let us do these numbers in our head. So I have the product here and the division. So I need to write 1/3 minus 3 minus 1/2. So if you cannot, you can go to the scratch paper or use your calculator in the fraction mode. 1/3 minus 3 minus 1. Because these two are supposed to be added, these two should be subtracted. So that's the case. So minus 1/2, sorry. Yes? And then the common denominator is 6. This is 2 times, this is 6 times, and this is 3 times. Yes? So it becomes minus 19/6. Okay, so it becomes x to power minus 19/6. Yes?
Didn't you say that 3 divided by 2 should be added?
Yes, but they are added in the denominator. When they go to the numerator, both of them will be negative. So these are very important things. If you don't understand, please let me know. So if I have x to power m divided by x to power n times x to power m, sorry, x to power p, this becomes x to power m minus n minus p. The reason is that we have x to power m. This becomes x to power n plus p, and then I have to write x to power m minus n plus p, and then when I open it, it becomes m minus n minus p. Is that understandable now?
Yes, no, it is. I forgot that there was a bracket. Yes, it is.
Yes, yes, you need to have these brackets. But this is very important. This is why I'm saying you need to be skillful in these calculations. Otherwise, it would be a very long calculation. But it is very important that whatever is in the denominator, they are added. And then you want to subtract the exponents, the one in the numerator minus the one in the denominator. But that minus sign goes for all the powers in the exponent. Yes? So if I want to give you a rule of thumb, if you want to combine something like this, you can write x. You can add the numbers in the numerator, all of them. You can subtract what are in the denominator. So that's the rule of thumb. Okay, so now let us calculate this one. So it becomes minus 2/3. Again, what should I do here? You see, 1/5 in the numerator is positive. These two appear in the denominator. So minus 5 minus 1/2. And then if I simplify this, 2 times minus 10 times minus 5 times. So it is minus 53 divided by 10. Yes? And then here, and both of them are negative. So minus 3 minus 1/2, it becomes minus 7/2. So everything is now in order. Now you take the derivative. H prime of x is equal to. So 5/3 is here. Let me do it in my head, yes? So 5/3, this will go down. I multiply these two numbers. 5 times 19 is how much? Is 95. 3 times 6 is 18. And then x to power 1 unit less becomes minus 25/6. Okay, when I go here, minus 53/10 goes down. Minus minus becomes positive. 2 and 5 are simplified, so it becomes 53/15. And x to power 1 unit less, it becomes minus 63/10. And then finally, you will get minus 7/3 x to power minus 9 over 3. Sorry, I was impatient actually if I want to explain all the details, but I don't think it's hard. So that's the final answer. So there are some simple calculations regarding how to add or subtract simple fractional numbers. Okay, I hope that you understood everything here. Let me just ask you one more question here. So how we can solve that problem? Number 4. What I make it a little bit simple because my point is something else. Assume that I have a function L of x, then I have the third root of 2x to power 2. Okay, this is simple. Okay, I just want to see how you solve that problem. I will for you 2 minutes. Okay. Yeah, okay. So can you just tell me, you just wait 30 seconds now, and then I ask you. Okay, now if you want, you can say, how should I start for this problem?
You can convert it into a fraction, so you run it 1 over, and then the statement inside the.
So what do you do with this 2 here?
And then to the power of 3.
So.
No, I keep it for now, and just put parentheses.
So what you are saying is that you write it in this form. Yes.
Yeah.
And then.
Oh no, wait! I made a crucial mistake. So never mind.
Yeah. Okay. So this is not the correct way of. This is also doable, but any other opinion? Come on, nothing.
Can't we take the square root of 3 on the whole?
Yes. Square root of 3.
Then we get 2 to the power of 1/3.
Yes.
Times x to the power of 2 divided by 3.
Yes, that's correct. So what you are saying is essentially, if I have a product here, I can write it as the third root of the first component, which is just a constant, multiplied by the third root of the second factor, which is x squared. You don't need to bother about this because that is a constant. Third root of 2 is a constant, so it's a multiplicative pre-constant. Yes? So what you need to concentrate is here. You even don't need to change the form of this function at all. This is a constant, not a function. Yes? So if I want to write it, I would write, so my guess was correct. So it might be some of you are confused. Okay? So this part, you need to write it as x to power 2 over 3. This is a very simple problem, but you need to understand it. So now my function is this number, a constant, multiplied by this function. So then if I want to take the derivative, I don't care about this constant. Actually, I write it there. And then I take the derivative of only this part. So you really don't need to write these 2 to power 1/3. There is no point for doing that. If you write it, it's not wrong, but just keep it like this. And then 2 over 3 goes down. And then I will have x to power 2 over 3, 1 unit less. But still, I keep that one. You see, 2 multiplied by that divided by 3 is 2/3 root of 2 divided by 3. And then I have x to power minus 1 over 3. So if you want, you can stop here. If you want to simplify it more, you can write 2 times the 3rd root of 2 divided by 3. Then I will take this to the denominator, makes the exponent positive. And if you want to, you can write it as the 3rd root again. Okay, so yeah, if you are on the wrong track, you need to take a lesson of it and start it somehow that you can study it further and remember. So this is the way that you need to look at this simple problem. So this function was not complicated at all, but the point is that you need to understand how to decompose it. Okay, so more or less, I think I covered everything that you only need this formula. So you see that we have a very simple formula, but we were able to solve a lot of problems, a diversity of problems using that simple formula. Okay, one thing that I want to mention, I have written here that C should be a constant, but now let me emphasize here. So for example, if I give you this function, and I ask you to differentiate this function, you are not allowed to use that rule, because in that rule, x is x, the exponent is a constant. This is different from this function. If I give you this function, x to the 2, yes, you can use that formula because x is x and 2 is a constant. But if I interchange them, if you take the derivative, you say x goes down, and I would write x to power minus 1. This is wrong. Okay, so be very careful. You are allowed to use this formula only if the exponent is a constant. Even if I ask you what is the derivative of this function, you are not allowed to say that I take x down and then I would write x minus 1. That is also wrong. So that is also one point that I want to mention because I have seen students make mistakes. This is not at the level of your lesson. You need to wait for university for that. But this is exactly at level of Math 3C. I will talk about this today. Okay. Okay. If you don't have any questions here, I want to go to the next function. I want to add 2 more functions into that table. Most part of this chapter is adding functions to that table. Okay, so you will learn how to differentiate trigonometric functions like sine, cosine, and tangent, and then you will also learn how to differentiate logarithmic functions. Okay, so these are the functions that we will add to that table. Okay. So let me change my function to another important function. Okay, so before adding it there, so let me write this. I have my function f of x equals to this famous number, Euler number. E is the Euler number. This is a very lengthy lesson from Math 3C. I'm not able to cover all part of it, but I will actually mention all salient points here. So Euler number. This is also a very famous constant number in the mathematics. It's called the Euler number. If I remember correctly, it is 2.7. I don't remember the next one. But this decimal points will never end because E also, like the pi number, is an irrational number. So pi and E are two very famous constants in mathematics. Pi is 3.14 something. You are familiar with that. Another constant number is called the Euler number, and that's also an irrational number, 2.7, etc., etc. That's approximately 2.7.
I think it's 2.7 and 1/8.
Ah, okay. So it's yeah, okay. So I remember if I want to keep it up to the 2 decimal points, it is 7.2, but it will continue as you said 1/8, etc. Okay. Now assume that I have that particular number as the as the base, and I have x as the exponent. So it means that this is different from here. Yes, here x, the variable, is in the base, the constant is in the exponent. But here I have one particular constant, one special constant e in the base, and I have x at the exponent. And my question is that what is the derivative of this function? Okay, so I just want to tell you what is going to happen, but I'm not able to cover all the details, okay? So if I want to calculate the derivative, there is only one way for me to do that, and that's the definition of derivative, yes? So I know that f prime of x is equal to the limit of f of x plus h minus f of x divided by h when h goes to 0. Okay, now for this function, let us write it and calculate the limit. So here I have h in the denominator, h goes to 0. Instead of, so let me put this minus sign here. Instead of f of x, I can simply put e to power x. Okay, now what should I write instead of f of x plus h? Hello? E to power
X plus h.
Exactly. E to power x plus h. So now my point is to calculate this limit, but this limit, calculation of this limit is not that easy. I'll just remind you something. Even in Math 3C, we were not able to rigorously calculate this limit. The logic there was a little bit convoluted, okay? So here, instead of e to power x time plus h, I can write the limit of e to power x times e to power h. E to power x times e to power h is the same expression. And then I have minus e to power x divided by h. H goes to 0. And then I can factor e to power x out. This becomes e to power h minus 1 divided by h. H goes to 0. So let me write it a little bit different. I write e to power x here, and then I write e to power h minus 1 divided by h. H goes to 0. Okay? So you see, this is not a constant, of course, but as far as this limit is concerned, x is a constant here, because what I am changing, what I'm varying is h. I am just making it smaller and smaller. I am not touching x at all. So it means that for calculating this limit, this part is irrelevant because it's not a constant, x e to the power of x, but it is fixed. It is there. By changing h, by making h smaller and smaller, I am actually affecting this part. And then this is a famous limit, okay? So I have talked about this in Math 3C. You don't need to be worried about that, but I just remind you that this limit, the calculation of this limit is not as simple as the other limits. There should be other tricks to solve this, to calculate this limit, but it turns out the value is exactly equal to 1, exactly. So this means that this limit is 1, so I multiply it by e to power x, so then it becomes e to power x. And that is a very, very unique property of this function. This is the only function in the universe whose derivative is equal to itself. Yes? So now I can remove this question mark, I can remove this question mark and write the function itself. It's very, very interesting, yes? So if you take that very particular number, then this limit turns out to be equal to 1, and the consequence of that limit is equal to 1 is that the derivative of this particular function, special function, is equal to itself. And that's the only function with this property. Okay, so now I want to add this into my table. That is also you learned in Math 3C. But in Math 3C, you learned a little bit more. So if you remember, you had K here. So let me put C. Wherever I want to write a constant, in your book it is written K because constant in Swedish starts with a K, but here let me write C. So e to power cx, I want to know the answer yet. I know the answer if C is equal to 1. It becomes the function itself according to this rule. But now if I want to calculate e to power cx, so I need to write a new function, f of x e to power cx. This part is only for those who are interested to know why these rules are correct. Otherwise, you can just simply ignore what I'm saying, and then you can just use the formula. But that is just killing mathematics. Yes, in mathematics, you need to know somehow the reasons as much as possible. So here, if I want to calculate a derivative, let me just do it quickly. What I do is exactly the same thing. I cannot do anything else, yes? So what I can write is that f prime of x is the limit. Let me do this part quickly. So I put h in the denominator. H goes to 0. Then I would write my function here. Then I would write cx plus h. Yes? So I have replaced x with x plus h everywhere. More or less, I use the same trick. So it becomes e to power cx plus ch. So I can write it as cx times ech. And then minus e to power cx divided by h. H goes to 0. And then I can factor e to power cx out. And then what is left for me is e to power ch minus 1 divided by h. H goes to 0. Exactly, I did that before, but now the problem is that this limit is exactly equal to 1. This is similar to that, but unfortunately I have a c there, so I need to take care of that c. The trick is to change your variable, so I will take ch to be a new variable, which I call it capital H. Okay? Then what will happen? Then from here, I realize that h becomes h over c. Now my goal is to calculate the limit of e to power ch minus 1 divided by h when h goes to 0. What can I do? I want to replace everything in terms of the capital H instead of a small h. Okay? So, and then what will happen here? I will have e to power capital H minus 1. Instead of little h, I put capital H divided by c. It is clear that when a small h goes to 0, if I multiply it by a constant, still the capital H is also going to 0. Okay, and then what happens? This c in the denominator goes into the numerator, so it becomes c, let me write it in this way, c times e to power h minus 1 divided by h goes to 0. Okay, but this is again my famous limit, yes? It doesn't matter if the name is little h or capital H. If this limit is equal to 1, that limit is also equal to 1. But I have a constant c here, so this becomes c. Okay? So now I understand that this limit is c, so I have to multiply it by e to power x, so the answer would be c e to power cx. So this is why in Math 3C you had this formula. So if I have e to power cx, the answer would be c goes down, the constant goes down, and then you repeat the whole function. Yes? C goes down, and it repeats the whole function. Do you know when the lesson ends? Is it 40 or 20?
40.
40, okay, good. Okay, so here, this is the formula. If you don't like that type of things to really deeply understand, you don't need to be worried at all. This doesn't play any role for you. You just need to know why this formula. So you need to know how to use the formula, okay? So if I have exponential function where e is that famous number, and that the exponent is a number multiplied by x, if you want to differentiate it, just bring this constant down and repeat the whole function in front of it. Okay? But there is a natural question coming in. You might say that, okay, if I choose this very special number for the base, that is the formula. But most of the time, I am not working with this number. What happens if instead of e, I have just simply 2 to power x? Yes? So what can I do here? So this is also a good question. What will I have if I have 3 to power x? You just told me how can I differentiate this if the base is very special number of this number. But what happens if the base is not that? Okay, that would be the next one, which also you studied in Math 3C. So let us discuss about that. I don't know how many of you remember how we can answer this.
I think we use the logarithms, right?
Exactly. Thank you. So if you want to, for example, let us concentrate here. Let us try to see what happens. My function is 2 to power x. This is the first time that I want to find the derivative of a function, but I don't want to use the limit process because I have a better way to do that. So instead of writing this, hopefully you remember e to power ln of a is what? Do you remember? This is the natural logarithm that you had in Math 3C. Natural logarithm, so if you have forgotten, let me just quickly remind you. When I say ln,
That should be just a.
so yes, exactly. So when I say ln of a number, what I means the logarithm of that number where the base is chosen to be this special number. This is called the natural logarithm of a. Okay, so this is the definition of the natural logarithm. So ln is indeed a logarithm. So any property that logarithm enjoys, this ln also enjoys. For example, if you probably know that logarithm of a in base x, for example, plus logarithm of b in base x is equal to logarithm of a times b in base x. So that is where one famous property of logarithm that you have studied in Math 2C. Okay, so now if instead of x, let me replace x with this e. So then it becomes logarithm of ab in e. But because this happens a lot in mathematics, instead of writing logarithm in base e, people write simply ln. So it becomes ln a plus ln b is equal to ln ab. So these sort of properties of logarithm you have studied in Math 2C, and in Math 3C we introduce you the notion of natural logarithm. So, and then one famous formula for natural logarithm that you have to know is e to power ln of a is simply a itself. It's a very, very important property. Okay, so now let us see what we can do here. Here, instead of 2, I can write e to power ln of 2. Why this is correct? You see, e to power ln of any number is equal to that number itself. So if I ask you what is a better name for this, you would say simply 2. And now I have an exponent x on top, so I put x here. So hopefully you understand. If you don't, please let me know. What I have done, I have copied and pasted the x part, but instead of 2, I have written it in a fancy way. using this formula. And the reason that I do it, it becomes clear shortly. Now I have an exponent raised to another exponent, and this is also a Math 1 problem, Math 1C. If you have any number, let me write any box to power m, and then you have it another power, then you write the same box and you multiply the exponents, yes? So here I can do the same thing. So I can write e, and I multiply ln of 2 by x. Now, if I ask you what is the derivative of this function, you can answer me, because we just answered it for e to power a constant multiplied by x. If you compare this function here with this function, e is the same e, x is the same x, and now ln of 2, which is a constant, is playing the role of this constant c. According to this rule, c is supposed to go down, and I am supposed to repeat the whole function itself for the derivative. So this means that the derivative of f is equal to the constant ln 2 goes down, and then I am supposed to repeat the whole function in front of it. But nobody writes this so complicated, because this one is equal to this one. Okay? So at the end, I will get rid of this one. It served me to find the derivative. Now I want to get rid of it because it is expired now. So yes, I replace this one with this one, which is much simpler to write. So then it becomes ln of 2 multiplied by 2 to power x. And then this is the derivative of this function. So, and then you realize that there is not something important about 2. If I have 3, the only thing that happens, this here would be 3, here would be 3, 3, at the end would be this. So what I write as the final one here, so I would say that if I have, let me make it a little bit clear. So let me start writing it here. If I have a to power x, but here a should be positive, because if a is not positive, sometimes this becomes undefined, yes? If that's negative, for example. And then the derivative of this function is a to power x, okay, ln of a. So the derivative of a to power x is this one. I have done it for 2, but there is no important point about 2. You can replace it by any positive number that you like. Because, by the way, you know that the number in front of a logarithm should be non-negative, otherwise it's not defined. You had this one in Math 3C as well, but you had a little bit more, okay? So what happens if I also have this constant here? Okay? Then it becomes c goes down as well, and then you will have an x here. Okay, so why is that the case? Exactly like this. For example, assume that I have f of x equal to 2 to power x, 2 to power cx. Instead of this, instead of 2, I can just write it like this. I copy and paste this cx part. Instead of 2, I write e to power ln of 2. But then I need to multiply them, so it becomes e to power c ln of 2 times x. But what is the point? The point is that now this will play the role of my constant. So if I want to take the derivative, this is supposed to be a constant, so the constant goes down. Because this is a constant, ln of 2 is also a constant, multiplication of 2 constants is a constant. So it means that this will go down, and I have to repeat the whole function in front. Yes, but the whole function is nothing except 2 to power cx. So it becomes c ln of 2 times 2 to power cx. So you see a c goes down. And there is nothing particular for 2, so you can replace it by any a. So this is the general formula. So if you have a number, a fixed number to power c times x, If you want to differentiate it, c goes down. Then you repeat the function in front of it, but you need to remember also multiply it by ln of a. Of course, that is also the same, but I am multiplying it by ln of e. But this is also famous. Ln of e is 1. This is why you don't see ln of e here. So actually, this is the more general formula. Okay, so let me write the special cases here. So special cases for the one above. What happens if I have e to power x? This is famous. Its derivative becomes exactly equal to this. The reason is that here c is equal to 1. Yes? And then I would also assume that what happens if I have e to power minus x? The answer becomes minus e to power minus x. So special cases, yes? Yeah, you don't need to memorize it. So these special cases are not in the formula sheet. Only the ones in black are given to you in the formula sheet. Okay, questions? Okay, I want to finalize this by an example today. So just try to solve some examples using these formulas. You see, because I have promised to start everything from scratch, I'm not counting on your knowledge from Math 3C, but we go a little bit slower. So all these things that I have talked about is actually 2 pages in the book. Okay, they have gone through it very fast. And by the way, I will write on a school soft that which pages to read and which exercises to do, okay, to make sure that you are on track. So let me start a new example, just 2 or 3. So example, differentiate. So number 1, let me start with a simple example. F of x is equal to x squared plus 2 to power x. Yeah, this is the simple example, but shows you to appreciate the difference between the formula on the second row and the formula on the last row. Okay, so this is called exponential function, but this is called polynomial function. Okay, if the base is constant, this one is variable, it's called exponential function, but the other way around is called the polynomial function. So the second row works for the polynomial functions. The last row works for exponential functions. Okay, so how should I take the derivative? I have the sum rule, the derivative of the first one plus the derivative of the second one. If I ask you to calculate, you calculate the derivative of this, it becomes 2x using the second row, but this is the last row. So it becomes 2 to power x multiplied by ln of 2. That is the answer to this. Okay? But for example, at this stage, if I ask you take the derivative of this one, you don't know. If I multiply them and I ask you find the derivative of this, it needs the product rule, which we haven't studied yet, but we can solve this one. Okay, so let me just give you another example. So say g of x is equal to, I have e to power 3x multiplied by e to power x minus 2 e to power minus x to power 2. So assume that I want to differentiate this function. Okay, so again, that's a product. We don't know the product rule yet, but even if we know about it, it's better to expand it and just multiply, simplify, and then differentiate. So here, if I want to take the derivative to differentiate this function, what I do, I keep it for the time being, But then I can use this algebraic identity to expand this. This becomes the first one to the power of 2, e to power x to the power of 2. It becomes e to power 2x because I'm supposed to multiply it. So the first one to the 2 becomes e to power 2x. 2 times the first one times the second one. 2 times the first one times the second one gives me a minus 4. And then I am supposed to multiply these two. E to power x multiplied by e to power minus x becomes e to power x plus minus x, which becomes e to power 0, which becomes 1. So 2 times the first one times the second one is just simply minus 4. And the second one to power 2 becomes 4 for the same reason, e to power minus 2x. But still, it's a product, so I am not done yet. I have to multiply this inside. So what happens, this becomes e to power 3x multiplied by e to power 2x. So it becomes e to power 3x plus 2x. It becomes e to power 5x. So the first one is e to power 5x. This one multiplied by that is minus 4 e to power 3x. This one multiplied by that is 4 e to power positive x, because 3x plus negative 2x is just simply x. Now everything is in order, so I can use the formula here to calculate the derivative. So let me just write it here. So the derivative is equal to this one, 5 goes down, and I have to repeat the function itself, so it becomes 5 e to power 5x. Minus 4 is there. 3 is supposed to go down. So 3 times minus 4 is minus 12. And then I am supposed to repeat the function itself. So it is e to power 3x. And then I go to the next one, and this is the most famous function whose derivative is equal to itself. So it becomes 4 e to power x. And that would be the derivative of this function. Okay, so that was actually a very compact review of what you have learned more or less so far about the derivatives in the previous course. Okay, so it's very crucial. Of course, some of these questions are a little bit harder, but for Math 4, these are level 1 problems. So you need to know that you need to improve your skills a little bit more. Okay, I want to stop here. If you don't have any questions, we can continue next time. Please follow up what I read on a school soft. Sometimes I have some delays, but I will do them as soon as I get the time, so before next session. So please read to see which pages of the book you need to study and which problems you're supposed to do. Any questions? No?
No.
Okay, have a nice weekend.
Thank you for the
You're welcome.